Welcome all. In continuation to our lectures on thermodynamics questions, this is the second lecture. So I have tried my level best to include wide varieties of questions so that all concepts are included, and I'm not saying that you will get the same questions as it is, but somewhere definitely I personally feel that concepts related to this will be touched in examination. Chalo, let's get into the subject. Now, this is the first question. This is MSQ question. Now, a good question. During melting of ice at 273 Kelvin at atmospheric pressure, he has given some options. Means ice is melting. Let us take ice in a container. This is the ice. How can ice melt? Definitely by absorbing heat. So it melts only by absorbing heat. So it is absorbing heat. Then it starts melting. You know, my dear students, when ice melts, it contracts. When it contracts, the volume decreases. When it contracts, the volume decreases. Means if I take ice as a system, it is absorbing heat, and thereby it is converted into liquid, that it is melting. So means if I take this as a system, heat is supplied, so heat supply is positive, and when ice melts, the volume decreases. All these I had explained in my thermodynamics class, why it contracts because of cage-like structure, hydrogen bonding. All these I had explained in my regular classes on plus. So when ice melts, it contracts, the volume decreases. Means the atmosphere is doing work on our system, that is ice. So there is work transfer. That's why the volume is decreasing. So whenever the volume is decreasing, it means work is done on the system, Okay. Now, from the first law of thermodynamics, we know that d dash q is equal to du plus d dash w. Okay. Now observe carefully. This is positive and this is negative. So I will write this as d dash q and is equal to du plus of minus w. Why are you writing minus w? Because work is done on the system. So you take onto this side. So d dash q is plus w. This w will come to this side, is equal to du. And you know, my dear students, it was on the right hand side, it is negative. So when you take it to the left hand side, it will become positive. And heat supply is already positive. When these two are positive and du will be positive, means internal energy is increasing. The common sense says it is absorbing heat, therefore it is melting. So heat supply is positive and work is done on the system. Means both energy interactions are added to the system. Definitely when work is done on the system, because it is contracting, so it is, when it melts, it contracts, the volume is decreasing. So work is done on the system. So therefore energy is transferred to the system. Heat is supplied to the system. That's why it is melting. So both are added to the system. That's why the internal energy increases. Now let us see what are the options. Positive work is done by ice. No. Ice is not doing work, whereas work is done on the ice by the atmosphere. So this is wrong. Positive work is done on the ice by atmosphere. Yes, positive work is done on ice by atmosphere. So this is absolutely correct. The internal energy of the system increases. Yes, the internal energy increases. The internal energy decreases. It is wrong. So options are B and C. Wonderful question. Options are B and C. Hope you have understood. Because when ice melts, it absorbs heat. When ice melts, the volume decreases. So thereby, when the volume decreases, means work is done by the atmosphere on the system, on the ice. So therefore, energy is transferred in the form of work to the system. Both are added to the system, so its internal energy increases. So therefore, the internal energy increases and positive work is done on the ice by atmosphere. This is correct. Next question. Let's take this. Again, this is MSQ question. 1 mole of monoatomic ideal gas undergoes a cyclic process as shown in figure. So please look at one. It is on TV coordinates, that is temperature volume. It is on TV coordinates, that is temperature volume. And look at, my dear students, it is an ideal gas. Now what is it saying? Process 1 is isochoric. Arey yaar, if you take volume here, अगर आइसोकोरिक होता है it will be constant volume. Isochoric is constant volume. On TV diagram, isochoric should be vertical. When volume is constant, it should be vertical, but this is not vertical. This is not process one, this is one, is isochoric. It's not isochoric, it is wrong. Process 2, in process 2 gas absorbs heat. Dekho, what is process 2? Process 2 is isothermal expansion. Why are you calling it as expansion? Because volume is increasing. I have told you very clearly in classes, in my regular plus classes. In isothermal expansion, heat is supplied to the system. Kaise? I explained something like this. Let us take so many small weights. So if I remove the weight, what is happening? The gas expands. When the gas is expanding, work is done by the system. When it expands, to do that work, it is coming from its internal energy, so the temperature decreases. But to maintain the same temperature isothermal, we have to supply heat. Therefore, during expansion, heat is supplied. So under isothermal conditions, when the volume is increasing, when it is expansion, it means heat is supplied. And there is one more isothermal. Now it is moving to the left. So therefore, volume is decreasing. It means compression, means isothermal compression. So when you are compressing, that energy is transferred to the fluid, temperature increases. But to maintain the same temperature, energy should be rejected. So therefore, during isothermal compression, heat is rejected. During isothermal expansion, heat is supplied. So this is isothermal. And what is happening? Therefore, as it is compression, heat is rejected. It is QR, heat is rejected. So in 2, heat is supplied. In process 2, gas absorbs heat. It is correct. In process 4, heat releases. Yes, it is releasing heat. Absolutely correct. And process 1 and 3 are not isobaric. Dekho, please listen carefully. He says 1 and 3. This is 1 and this is 3. What is the diagram? So let us see. He says 1 and 3 are not isobaric. Let's see, how do we represent isobaric? Let us see, my dear students, how do we represent isobaric? Ek baar dekhna. Let's see how isobaric lines are represented on TV diagram. Dekho, look at. You know that PV is equal to MRT. He says isobaric. So M is constant, R is constant, isobaric pressure is constant, volume is directly proportional to temperature. Great. And look at, my dear students, understand carefully. So I can write V is equal to MR by P into T. It's something like, or this can also be written as T is equal to P by MR. I repeat, T is equal to P by MR into V. T is equal to PV is equal to MRT. Yes, I have rearranged the equation. T is equal to P by MR into V. It's something like, on Y axis we have temperature, and this is slope. P by MR is slope. And on X axis you have volume, so it is Y is equal to mx. It is a straight line passing through origin. Why straight line? Because he says isobaric. Isobaric means pressure is constant, mass is constant, R is already constant, MR are constant. In isobaric, pressure is constant, this completely is constant. Means slope is constant. When slope is constant, it is a straight line. So Y is equal to mx is a straight line passing through origin. So therefore, isobaric on TV diagrams are something like this. These are isobaric. So definitely, this 1 and 3 are not isobaric. 1 and 3 are not isobaric. So this is correct. He says it is not isobaric. Yes, it is correct. So correct options are B, C and D. This is also a good question. So let's move to the next question. Now, let's move to the next question. Dekho. Now, this is also a good question, sirs. Now, read the question. A thermodynamic system is taken from initial state I. This is the initial state I. With internal energy UI is equal to 100. The internal energy here, UI is given as 100. Here the internal energy is given 100 to the final state F along two different paths. It is starting from here. I to F is one path. I to F is another path. It means the system is taken from initial state I to the final state F by two paths. One is IBF, other is IAF. There are two paths. Okay. Now, I shown. Okay, the work done by the system and UI is given. The work done by the system along AF, IB and BF are also given. So work done along AF, listen carefully, AF is 200 and this is given as 200. Work done along IB is 50, all are in joule, and work done in BF is given as 100. Okay, The heat supplied to the system along IAF is QAF and IB is QIB and QBF is the heat supplied along BF. If the internal energy of the state UB, B internal energy is given, here the internal energy is given. What is the internal energy given? 200. And QIAF is given, sirs. QIAF is given as 500. Then what is he asking? QBF by QIB. He is asking what is the ratio of heat transfer in BF to the heat transfer in IB. Very simple, sirs. Let's move neatly. So there is no problem at all. Let's move very neatly. आगे बढ़ते हैं, sirs. एक second, please. I think it's okay. Right, very good. Now, QIAF is given. So let me apply first law of thermodynamics for IAF. देखो एक बार. So dear students, QIAF is equal to, now let me apply. D dash Q is equal to du plus d dash w. Let me apply this for IAF. Why are you applying for IAF? Because complete heat transfer for IAF is known. So I am applying for IAF. What is the heat transfer for IAF? It is given as this. I am applying for IAF. So what is the heat transfer for IAF? It is 500 and that is equal to du. What is du? Change. We are moving from IAF. This is the initial state and this is the final state. Internal energy is a property. It will not depend on path. So therefore the change for IAF is UF minus UI. So UF minus UI plus work in IAF. Already IAF work is given, I think. Where is this? Dekho, I can write IAF work as, please listen carefully. Work in IAF can be written as work in IA. Very good. Plus work in AF. Work in AF. I repeat, sirs, work in IA plus work in AF. Actually, this is PV diagram. So it is a constant volume process. You just see IA. IA is a constant volume process. It is a constant volume process, IA. So for constant volume, work is 0. So whatever the work is required for IAF, whatever the work is done in IF, it is AF only. Already AF work is given. It is 200. So work in IAF is equal to IA plus AF. But IA is a constant volume. For constant volume, work is 0. So total work for IAF will be equal to this plus this. But this work is 0 and only this work is left. What is that? AF, it is 200. So therefore, it is 200. So already you know UI. I think UI is known. It is 100. So 500 is equal to UF minus 100. So UI is 100. UI is 100 plus 200. So I think you are getting UF as kitna raha, sir? 7. This is plus 100. I think it is 400. Let me check. 600. Yes, it is 400. So UF we have calculated and it is 400. Let me erase this. UF we have calculated and it is 400. UF is 400. So let me erase this. We have calculated UF. So there is no problem at all. Now what I do is, dear students, a second please. What we do is, right, let me apply for IBF. For IBF, D dash Q is equal to du plus d dash w. I am applying for IBF. So what is the heat transfer for IBF? So heat transfer for IBF is equal to, dekho, it is from IBF. So for IBF, final is this, initial is this. So internal energy change is UF minus UI because it is a property, plus work in IBF. What is the work in IBF? It will be work in IB plus work in BF. What is the work in IBF? It will be work in IB because it is a path function. Work in IBF will be work in IB plus BF. IB is 50 plus IB plus BF. BF is given as 100. Very good. So therefore, QIBF is equal to UF. Already UF is calculated by us, it is 400 and UI is 100 plus 100 plus 50 is 150. So therefore ये आ रहा है QIBF is equal to 450. So the total heat transfer in IBF, let me repeat, sirs. The total heat transfer in IBF is 450, but he is not asking QIBF. He is asking QBF by QIB. So we got QIBF as QIBF as 450. Let me erase this, sirs. Let me erase. We got this as 450. Okay. Now let's try to find out QIB and QBF. We'll do like this. Don't worry. Don't worry. And you know, my dear students, IB is given. So can we write this as UB is also given, UI is known. So let me apply first law of thermodynamics for IB. Let me apply for IB. So D dash Q is equal to DU plus D dash W. It is for IB. So what is the heat transfer for IB? I don't know. What is DU IB? I to B. It is final minus initial. UB minus UI. UB is 200 minus UI. UI is 100 plus work in IB. What is work in IB? It is 50. Already we know work in IB is 50. So therefore QIB is equal to 200 minus 100 is 100. 100 plus 50 is 150. Look at QIBF. Total QIBF is 450. So QIBF is equal to 450. But that can be written as QIB plus QBF. So QIB plus QBF. Okay. So 450 is equal to QIB. Already QIB is 150 plus QBF. So you get QBF as, anyone? We get QBF as 450 minus 150 is 300. And QBF, dear students, QIB is 150 and QIB is 150, QBF is 300. So he is asking QBF by QIB. So QBF by QIB is equal to, what is QBF? It is 300. And what is QIB? QIB is 150. So this will be equal to what? 2. So the answer, it is a fill in the blank question. So the answer is 2, 2, 2. This is also a good question. Okay. Now without wasting time, let's move to the next question. Now, an ideal gas is expanding such that Pt square is equal to constant. Let this constant be Pt square. The coefficient of volume expansion. You know, I designated coefficient of volume expansion with beta. That is 1 by V dou V by dou T at constant pressure. This is our coefficient of volume expansion. He is asking, then it is an ideal gas. If it is an ideal gas, we have PV is equal to MRT. No problem at all. PV is equal to MRT. Dekho. Can we write this as, dear students, either dekho, Pt square is constant. So what is the value of P here? So dekho ek baar, what is the value of P here? Can we write P as VRT, MRT by V? Can we write P as MRT by V? Yes. So let me substitute here. P is MRT by V. This is from thermodynamic relations chapter. This is an ideal gas. Therefore, I have used ideal gas equation. P is MRT by V into T square is equal to constant. No problem at all. Ab dekho. What do you want? Dou V by dou T. So dekho, I'll write this as MRT. So yahan likhenge sir. I'll use space effectively. Okay. Now MRT by V. I'll write this as T cube. Why T cube, sirs? Because why T cube? Because MRT into T square is T cube by V is equal to constant, or V is equal to MRT cube by C. V is equal to MRT cube by C. Up, let us calculate dou V by dou T. Let's calculate dou V by dou T at constant pressure. Dou V by dou T is, dekho, MR by C is constant. Okay. T cube. What is T cube? It is 3T square. T cube is, you are differentiating with respect to T. So it is 3T square. Now, dekho sirs, what is MR by C? Yahan se likho. MR by C. Dekho. MR by C can be written as MR by C can be written as V by T cube. Let me check. MR by C is V by T cube. So therefore, dou V by dou T at constant pressure is equal to MR by C. What is MR by C? V by T cube. V by T cube into 3T square. Correct. So therefore, let me check. So this T square, this T is gone. So we are left with dou V by dou T at constant pressure is equal to 3V by T. But I want beta. But what is beta? 1 by V. So you bring V to this side. So therefore it will be 1 by V dou V by dou T at constant pressure. You bring V to this side. 1 by V dou V by dou T. This is equal to 3 by T. So therefore the answer is 3 by T. It is also a good question. Is it okay? Right. Next. Now, let us take this question. An ideal gas is taken through cycle A, B, C, A. This is one cycle as shown in figure. If the net heat supplied is 5 kilojoule, देखो, net heat supplied is 5 kilojoule and the work done, it is not down, it is done. Work done by the gas in the process CA. He is asking in CA. What is the work in the process CA? But please note down that he has interchange. Generally, we take pressure on this axis, volume on this axis, but he has interchange. Volume is on this axis, pressure is on this axis. Please be careful. What is he asking? He is asking work in CA. Let us try to see. Try to solve this. So it is a cycle. For a cycle, net heat is equal to net work. Already net heat is given. So देखो, already the total net heat is given. The net heat supplied bola hai, therefore it is positive. So net heat is 5. So net work is also 5 because from the cycle, from first law of thermodynamics for a cycle you get this. So sigma W is equal to 5. What does it mean? So work in देखो AB plus work in BC plus work in CA, AB, BC, CA, and that is equal to 5. Okay, no problem at all. He is asking work in CA. Let us check. Can you tell me what is the process BC? It is horizontal, but on this axis it is volume. Means everywhere on BC, देखो, this is volume. So everywhere the volume is constant. देखो एक बार, this volume is constant, this volume is constant, this volume is constant. Everywhere the volume is constant. So BC is a constant volume process. Please look at V is not on this axis, V is on this axis. Therefore, BC is constant volume. BC is constant volume. So work in constant volume process is 0. So ये निकल गया. So work in AB plus work in CA is equal to 5. Now he is asking work in CA, but to calculate work in CA, I need work in AB. AB क्या है sir? AB is a constant pressure process. देखो constant pressure process, constant pressure process, constant pressure process. देखो everywhere the pressure is how much sir? 10 Newton per meter square, 10. So therefore, for constant pressure process, work is given by P into V final minus V initial. It is a constant pressure process. So please note down that pressure is on this axis. That's why it is vertical. So work in AB is equal to pressure. What is the pressure here? 10 into change in volume. So this volume is 2 and this volume is 1. So therefore, look at the direction the process is occurring like this. So it means volume is increasing from 1 to 2. Volume is increasing from 1 to 2 means it is expansion. Expansion, volume is increasing. So therefore, it is a positive work. So final volume from A to B. A to B is a constant pressure process. This is a constant pressure is on this axis. Constant pressure. So initial volume is this. Final volume is this. Change in volume is 2 minus 1. So 2 minus 1. So therefore, 2 minus 1 is 1. 10 into 1 is 10. But unit check करेंगे. Newton per meter square is pressure and the volume is given in meter cube. So therefore Newton meter, so it is joule, 10 joule. So work in AB is 10 plus work in CA we don't know is equal to 5. So work in CA will be equal to 5 minus 10, that is minus 5. So where is that? It is minus 5. Yes, this is minus 5 joule is the right answer. So now in the next class you will be seeing questions on unsteady state flow, entropy generation. On entropy generation, I'll be taking different varieties of question. Entropy generation, second law, combination of heat engine and refrigerator. And next, third lecture will be the most important lecture. And thank you, my dear students. If you really like these classes, please show in comments key. If you like, please respond in a positive manner. If you don't like, then also you respond, ki classes are not good. I have no problem because every time we need improvement. Thank you, my dear students. And in lecture 3, we'll be seeing much on entropy questions and unsteady state, entropy and unsteady state and irreversibility. Third lecture will be very, very important. Thank you.